Hey everyone, welcome to this explainer. I'm Marcus, an OT engineer, and I'm here with Sarah, our lead AI architect. Today we're diving straight into a highly technical debrief on exactly how to modernize those legacy factory architectures from the ground up.
That's right, Marcus. If you're managing operational technology, you already know the factory floor is completely shifting. We're moving away from rigid, traditional automation and into environments powered by edge computing and adaptive AI. So we're going to tear down the entire transformation stack you need to actually bring those brownfield systems into the Industry 4.0 era. Let's get right to it.
All right, here's our agenda for today. First, we're covering the cost of downtime, followed by ingestion and edge compute.
Then we'll hit machine learning analytics and finally wrap up with closed-loop integration and the resulting ROI.
Kicking things off with Section 1, the cost of downtime and the financial bleed of legacy systems.
So before we even touch the technical stack, we have to establish the baseline stakes here, $22,000. That is literally the capital bleed per minute for unplanned downtime in heavy industrial and automotive plants.
It's massive. And when you factor in that legacy factories face an average of 800 hours of unplanned downtime every single year, just do the math. When a production line unexpectedly goes down, say a spindle seizes or a bearing completely shatters, it isn't just a headache for operations. It is an immediate, absolutely devastating hit to the balance sheet.
Right, so why are we facing these massive numbers? Well, it really comes down to the control layer. Traditional automation relies almost entirely on rigid programmable logic controllers, or PLCs. These legacy systems are built to execute static rules exactly as they're programmed, over and over again. The problem? They are completely blind to physical wear and environmental drift. If your facility's temperature fluctuates even a bit, or a machine component starts vibrating slightly out of spec, that static PLC, it's totally oblivious. It just happily runs the program until the machine literally breaks.
Exactly. And that is exactly why we absolutely have to transition from these rigid systems to a true Industry 4.0 architecture powered by adaptive AI. We're talking about systems that can learn, adjust, and predict those failures long before they ever happen.
Moving into Section 2, ingestion and edge compute, where we'll look at upgrading the OT hardware layer.
This is where we really get our hands dirty with the base hardware, figuring out how to extract data from brownfield machines that, honestly, were never designed to talk to a network. The technical blueprint for this transformation stack requires 4 distinct physical steps. First up, OT ingestion, followed by the edge computing layer.
Yep, and then step 3 is the software execution via machine learning analytics, and finally, closed-loop action.
And listen, if you skip even one of these steps, the entire architecture just falls apart. So let's break down that hardware foundation first.
Step 1 is OT ingestion. Simply put, you can't run analytics if you can't pull telemetry from your legacy equipment. So we use standard ingestion protocols to connect these, 30-year-old brownfield machines. We deploy OPC UA for complex secure data modeling. We use Modbus for older serial devices, and MQTT for lightweight publish-subscribe messaging. These basically act as the universal translators on your factory floor, pulling that raw, continuous telemetry right out of your aging assets. But here's the catch. Raw telemetry is completely useless if you process it too late. Sending all this continuous machine data all the way up to the cloud takes time. And in industrial automation, that kind of latency is just unacceptable. So that brings us to step 2, the edge computing layer. We achieve critical sub-10 millisecond latency by deploying lightweight vision models and TinyML directly on industrial edge gateways. We're actually racking hardware, like NVIDIA Jetsons or ruggedized industrial PCs, right on the factory floor, literally inches away from the machines. This lets us process the telemetry and make split-second decisions locally, entirely bypassing that slow cloud round trip.
All right, let's jump to Section 3, machine learning analytics, processing telemetry into actionable insights. Now that we have that sub-10 millisecond access to our machine data at the edge, we need the software layer to actually make sense of it all. This is where AI truly enters the stack, specifically through autoencoders. Now, these are unsupervised neural networks that are absolutely phenomenal for anomaly detection. We basically feed them continuous vibration and acoustic streams straight from the machines, and they learn exactly what a normal, perfectly functioning machine sounds and feels like. Exactly. So the very millisecond any environmental drift occurs, maybe it's just a microscopic change in the acoustic signature of a motor, the autoencoder flags it. It catches that drift on the acoustic stream way before a physical bearing shatters and triggers that whole $22,000 a minute downtime nightmare.
And alongside those acoustic and vibration analytics, we're also deploying convolutional neural networks, or CNNs, for automated visual inspection. These are deep learning algorithms that process video feeds from cameras mounted right there on the production line, and they are trained to catch physical defects in real time, literally down to the millimeter. So if a component is even slightly misaligned or a surface has a tiny microfracture, the CNN catches it instantly, right at the edge. Which brings us to Section 4, Closed-Loop Integration and ROI, moving from telemetry to enterprise action.
Because think about it, having a neural network detect a flaw is brilliant, but if that insight doesn't automatically trigger a physical response, your machine is still going to crash. We absolutely have to tie this AI telemetry back into the enterprise systems to actually prevent the catastrophic failure.
Right, so here is the exact closed-loop trigger path to make that happen. First, the AI telemetry output at the edge identifies an anomaly. Then, that data is immediately fed back into the SCADA system.
Exactly, which allows us on the OT side to immediately alert the floor operators and safely throttle or shut down the machine. But the beauty is it doesn't stop there. The system is integrated directly with your enterprise resource planning software, your ERPs like SAP or IBM Maximo. The telemetry automatically generates a prioritized work order in the ERP and actually dispatches a maintenance crew before the equipment even fails. That right there is a true closed-loop system. The machine diagnoses itself and essentially orders its own repair. It's incredible.
So what is the core business metric that actually justifies building out this entire transformation stack? It's a massive 85% reduction in unplanned factory downtime.
Yeah, by shifting from those rigid, static PLC rules to an adaptive, predictive AI loop, you are virtually eliminating those 800 hours of massive capital bleed that legacy factories suffer from every single year.
And the ROI really cascades across all operations. Because your SCADA and ERP systems are now acting on real-time machine health, you completely shift from calendar-based maintenance to condition-based maintenance. You're only fixing machines when they actually need it, which drives a massive 40% reduction in routine maintenance overhead.
Furthermore, those CNNs we discussed earlier for real-time visual inspection, they catch defects before bad parts even move down the line. And that delivers a solid 30% reduction in scrap and rework costs.
This blueprint isn't just theory, guys. It is absolutely the new standard for modernizing heavy industry. So we're going to leave you with this final thought to evaluate your own architecture.
Are your current PLCs truly preparing you for the future, or are they just counting down to your next $22,000 a minute failure? It is time to build a factory that actually adapts. Thanks for joining us for this debrief today.
Yeah, catch you on the next one.